Hi everyone, welcome to this episode of Keipert Labs. In this video, we're going to be discussing the concept of molar mass. Okay, so in the previous video, we introduced this idea of the counting unit of chemistry, which we call the mole. And so we said that the mole represents a standard number of particles of any substance, and that we specified that that number was 6.022 times 10 to the 23 particles. Okay, and so then we would say it's that many particles for every 1 mole. And so we said that 1 mole of any two substances will represent the same number of items, or same number of particles. Okay, so whether they're, a single kind of atom or a very large molecule or whatever, that this is the number of particles that would be involved in 1 mole of that substance. And we said then that you could, in order to get 1 mole, that you could measure out the relative atomic mass, that element's relative atomic mass, in grams. And so we give this particular concept a name, and we call this molar mass. That substance's molar mass. That is the mass of 1 mole. Okay, so the molar mass of 1 mole of that substance is we measure out its relative atomic mass in grams. So what that means, that all of a sudden we've taken something that's a very relative and abstract idea, and we've now turned it into something that we can use the periodic table for. Because the periodic table refers to or gives us a value for that element's relative atomic mass in the box. Okay, so for hydrogen, we would say it's 1.008 grams. Carbon, we would say 12.01 grams. Nitrogen, 14.0 grams. Oxygen, 16.00 grams. Okay, that all of these are values that we can read off the periodic table. All right. Now, in the previous video, we mentioned that using hydrogen as the standard for the mole. And said, okay, well, then this is the 1 mole is the number of particles in 1 gram of hydrogen. But what the chemists quickly realized, or realized after some time, was that hydrogen was a difficult sample to actually get with an accurate mass. So that it's like, okay, well, if you could get, if you wanted to get a sample of hydrogen, that different hydrogen atoms will have different masses. And so what they ended up doing was that they ended up shifting the standard to being carbon, because most carbon atoms are of a type called carbon-12, which is very common and very stable in its mass. And so it's the sort of thing that it became a better kind of benchmark, or a better standard, to say that 1 mole represents the number of particles in 12.00 grams of carbon. Okay, but so what we can do to work out the molar mass of any substance is to look at the periodic table and identify the relative atomic mass in grams. And so, so if we would say, all right, well, what's the relative atomic mass of iron, which is Fe, we could read it off the periodic table and say that it's 55.85 grams for every 1 mole. Okay, so we have units. So let's see if I can clean this up and kind of set down some boundaries here. So molar mass is mass of 1 mole of the substance, and it has units of certain number of grams for every 1 mole. And so this means we can set it up as a conversion factor. So we can use it as a conversion factor to go between mass in grams and moles in units of mole, okay, that we can use molar mass in units of grams for every 1 mole to help us to go between these two things. And in reality, what we're going to show as we kind of extend through the next few units is that moles is actually at the center of so many things of what we do in chemistry. And so being able to convert to moles gives us an incredible amount of power in being able to do chemistry calculations. Okay? Now, the great thing about this concept, aside from I just love kind of chemistry, but the idea is that this concept is not limited to elements. it also can work for compounds. And so for a compound, you just add up molar masses of the elements of its elements. So for example, if I've got carbon dioxide, 1 carbon and 2 oxygens, if I want to work out the molar mass, I can do 1 carbon plus 2 lots of oxygen. That's an O, not a 0. So I can look up the periodic table and I can say carbon is 12.01, and then oxygen is 16, so 2 lots of 16, it's that many grams for every 1 mole. So which gives me 44.01 grams for every 1 mole of carbon dioxide. Okay, so for any compound, and so there's some further examples for you to complete, that you just add up the elements, the atoms that kind of make up that compound. You look at the formula and you add the components together, and then that will give you the molar mass of that substance. So I mentioned just before about this idea that molar masses can be used as a conversion factor to go between mass and moles, and I'm going to show you how to do that just now. Okay, so looking at one of the kind of the follow-up questions from here is saying, all right, well, how many moles are there in 6.5 grams of carbon dioxide? So if you could weigh out a sample that had 6.5 grams, how many moles would that be? And so we've looked at this idea that molar mass, okay, which we could represent as capital MM. There are other ways to do it as well, but we're going to do that. We just calculated to be 44.01 grams for every 1 mole. Now, because it's a conversion factor, we could also set this up as for every 1 mole of carbon dioxide, I would have 44.01 grams. Okay, so I've got version 1 or I've got version 2. And so whichever one that I can use, I need to get me the answer that I'm looking for, I can use. So I've got 6.5 grams of carbon dioxide, and I'm trying to get units of moles in the end. So the units that I want over the units that I have is going to be version 2. So I'm going to multiply by 1 mole for every 44.01 grams, and I get a value of 0.1476 ... moles. Okay, so if I'm going to round off to 2 significant figures, which is what I'm provided with, then 0.15 moles to 2 significant figures. Okay, so I've used this molar mass as a conversion factor, just like I'm used to doing in my factor label method, to convert between mass and moles. Now, I could just as easily have said, okay, well, what mass, what is the mass of 0.15 moles of carbon dioxide? And I would use the conversion factor the other way around, because I want to go the other way, to go from moles to grams. Okay, so use it like you would with the factor label method as far as the units that you want over the units that you have, and keep having a go with those practice questions. Alright, time for a nice science joke. As ever, we'll finish with a nice little science joke for you. So I have this new theory on inertia, but it doesn't seem to be gaining any momentum. Thanks very much for watching. Bye for now.